we need to write the number represented by the blocks below. So here we can see that we have these blocks, which are ones, then we have these, which are tens, and we also have these blocks here, which are hundreds. So we know that if we have 10 ones, that's the same as having 1 10. And for hundreds, if we have 10 tens, that's the same as having 100. So if we imagine 10 of these tens blocks all stuck next to each other, that's the same as having 100. So to write the number represented by these blocks, we need to count how many of each block we have, starting with our largest blocks, so our hundreds. We have 8 hundreds, so we can write 8 as our hundreds digit. We have 9 of these tens blocks, so that's 9 as our tens digit, and we have 9 ones, so that's 9 as our ones digit. So we have the number 899. Now here we have 4 as our hundreds digit, we have 3 as our tens digit, and we have 6 as our ones digit. So that's 436. So notice it's always the ones digit on the end, then the tens digit before that, and then because we're writing 3-digit numbers, we have the hundreds digit before that. Now here we can see that we have 7 hundreds, so that's 7 as our hundreds digit. We have 8 tens, so we can write 8 as our tens digit. But here we don't have any ones, and it's really important that we write a 0 as our ones digit to show that we don't have any ones. That way we've written the number 780. But if we didn't have this 0 here, we would have written the number 78. But that would show 7 tens and 8 ones. So we need this 0 here as a placeholder to show that this 7 represents 7 hundreds and this 8 represents 8 tens. So again, in a 3-digit number, we need digits for our hundreds, tens, and ones. So if we don't have any blocks of a certain place value, we need to write a 0 as a placeholder. So now here we can see that we have 5 hundreds, but this time we don't have any tens. So we need to write a 0 as our tens digit. And then we can see that we have 5 ones, so that's 5 as our ones digit, giving us the number 505. Again, you can see why this 0 is important. If we didn't have this 0, we would have the number 55. But that would be 5 tens and 5 ones, not the 5 hundreds and 5 ones that we have here. We need to write the numbers below in digits. So for all of these numbers, we can see the word 100, and that tells us that our number will have at least 3 digits. First, we have 825. Now the best way to write numbers in digits is to write the hundreds digit and then remember that we need 2 digits after the hundreds digit for our tens and ones. We have 800, so we can write an 8, and then we have 25, so that's 25. Now we have 900, so we can write 9 for our hundreds digit, but to show that it's our hundreds digit, we need zeros in our tens and ones, because if we just have 900, we don't have any extra tens or ones. Remember, after the hundreds digit, we always need digits for our tens and our ones, so if we don't have any tens or ones, we need to write zeros as placeholders. Now we have 320. So that's 3 for 300, and then 20 is 20. And now we have 402. So we can write the digit 4 for 400, But remember, we need 2 digits after the hundreds digits for our tens and ones. So we need to write 2 as 02, so with 0 as our tens digit. If we didn't have this 0, we would have written 42, but that would be 42, not 402. Remember, if you see the word 100 in a number, you know that it has to have at least 3 digits. Now, let's see if we can represent these numbers using base 10 blocks. So first, we had 825. So 800 shows us that we need 8 hundreds blocks, and then for 25, we need 2 tens and 5 ones. Then we had 900. So that means that we need 9 of our hundreds blocks, but we don't need any tens or ones. Then we had 320. So we can show 3 hundreds and then 2 tens for 20. And because we have a 0 as our ones digit, we don't need to show any ones. With 20, we just have 2 tens and no additional ones. And then we had 402. So we can show 4 hundreds blocks, no tens blocks, and 2 ones. We need to write the numbers below in words. So here we can see that all of our numbers are 3-digit numbers. So if we remember that in a 3-digit number, the first digit tells us how many hundreds we have, then we have our tens digit, and then on the end we have our ones digit. That will help us to write these numbers. So first we can see that we have a 5 as our hundreds digit, so we can write 500. Notice it's 500, not 500s. If I'm talking about the digit, I might say that we have 5 hundreds in this number, but when writing the number in words, we write 500. Then we know that after our hundreds digit, we have our tens and ones digits. So if we take these together, we have an 8 and a 2, so that's 82. That means our number is 582. So with the word and after the word hundred and a hyphen between the 80 and the 2. Now for this number here, we have 7 as our hundreds digit, so we can write 700. But then after our hundreds digit, our tens and ones digits are both zeros. That means we don't have any tens or ones in this number, so we don't need to write anything else. Our number is just 700. Now here we have an 8 as our hundreds digit, so that's 800. And then after our hundreds digit, we have a 4 and a 0, so that's 40, meaning that our number is 840. And finally, we can see that for this number, we have a 2 as our hundreds digit, so we write 200. Then, after the hundreds digit, we have a 0 and a 1, so that's a 0 as our tens digit. So we have 201. Now let's take a closer look at these numbers. First, we had 582. So we can show 5 hundreds, 8 tens, and 2 ones. Now, for 700, we can show 7 hundreds, but because we don't have any tens or ones, we don't need to show anything else. Then we had 840, so that's 8 hundreds, and then 40, we have 4 tens. And finally, we had 201, so that's 2 hundreds, no tens, and 1 1. We need to partition the numbers below into hundreds, tens, and ones. So we need to remember that in 3-digit numbers, like we have here, the first digit tells us how many hundreds we have, then we have our tens digit, and the digit on the end is our ones digit. So first, we have 483. Now this 4 is in our hundreds, so it represents 400. This 8 is in our tens, so it stands for 80. And this 3 in our ones just stands for 3. So when we partition numbers, what we're doing is showing the value of each digit in the number. And we can represent the partition as an addition, because if we add 400, 80 and 3, we will get 483. Also notice that after the 4 in this number, we have 2 digits. So when we partition, after the 4, we have 2 zeros. After the 8 in our number, we have 1 digit. So when we partition, after the 8, we have 1 zero. So now let's look at 555. This first 5 is in our hundreds place value, so it represents 500. Then we have 5 in our tens, so that's 50. And then 5 in our ones just stands for 5. So if we add 500 plus 50 plus 5, we get 555. Notice when we partition, we only have 1 digit in each of our partitioned numbers that is not 0. But now we have 609. So this 6 in our hundreds represents 600. We know it's in our hundreds because we have 2 digits after the 6. So when we partition, we need 2 zeros after the 6. But now we can see that in our tens place value column, we have a 0. And we don't need to partition zeros. That's because whatever place value it's in, the value of the 0 is always 0. Zeros don't have any value in themselves, but zeros are still important because they give other digits the correct place value. So because we have this 0 here, we know that the 6 stands for 600. If we didn't have this 0, we would have the number 69, but that would be 6 tens, not 6 hundreds. So we don't need to partition the 0. We can move on to the 9, and because that's in our ones place value column, it just represents 9. And finally, we have 870. This 8 is in our hundreds, so it represents 800. 8 followed by 2 zeros, because we can see that in our number, after the 8, we have 2 digits. Then we have a 7 in our tens, so that's 70, and our ones digit is a 0. So again, we don't need to partition our ones digit because the value of a 0 is always 0. This 0 is important because it tells us that the 7 is in our tens, so stands for 70, and the 8 is in our hundreds, so stands for 800. But the 0 doesn't have any value in itself. So let's take a closer look at these numbers. First, we had 483. So we can show that as 4 hundreds, 8 tens, and 3 ones. So what we've shown here is the number 483, but we could also think of what we've shown as being 400 plus 80 plus 3. So that's what we're doing when we partition numbers. We're showing the value of each digit. Then we had 555. So that's 500, so we can show 500 blocks. 5 tens or 50, so we can show 5 10 blocks. And 5 ones, so we can show 5 1 blocks. That's 555. Then we had 609. So this 6 represents 600, so we can show 600 blocks. But this 0 in our tens shows that we have no tens, so we don't need to represent any tens blocks at all. And that's why when we partitioned the number, we didn't need to write anything to show the 0 in our tens. we just needed to show the 9 ones, and that gives us 600 plus 9, or 609. Then our last number was 870. So for 800, we can show 800s blocks. For 7 tens, or 70, we can show 7 10 blocks. But then we don't need to show any ones, which is why when we partitioned, we didn't need to write anything for the 0. Now, instead of using base 10 blocks, we can represent numbers in a different way. So we can use place value counters. So our first question, we had 483. So what we can do is show 400 counters, because if we have 400 counters, that gives us 400 altogether. Notice we have 100 written on each of these counters. Then for this 8 or 80, we can show 8 10 counters, because if we have 8 tens, we have 80 altogether. And for this 3 in our ones, we can show 3 ones counters. So using place value counters is a different way to represent numbers, and at first it can be a bit confusing, because even though the counters are all the same size, they represent different amounts. Remember, we need 10 ones just to make 1 10, and we need 10 tens just to make 100. So we would need 10 of these red counters to make something that's the same value as just 1 of these yellow counters. And we would need 10 of these yellow counters to make something that's the same value as just 1 of these green counters. So it can be confusing, but as long as we remember that the green counters represent hundreds, the yellow tens, and the red ones, this can be an easier way of representing numbers. So if we wanted to represent 555, we could do that using 500 counters to show 500, 5 10 counters to show 5 tens or 50, and 5 ones. Or with 609, we would need 600 counters to show 600. Then we have a 0 in our tens, so we don't need to show any tens counters, but we have a 9 in our ones, so we can show 9 ones counters. Or for 870, we have an 8 in our hundreds, so we can show 8 hundreds counters to represent 800. And we have 7 in our tens, so we can show 7 tens counters, because if we have 7 tens, that gives us 70. And then, because we have a 0 as our ones digit, we don't need to show any ones counters. What we've represented here is 800 plus 70, or 870. For the questions below, write less than or greater than. So here we need to compare numbers. First, we have 35 and 350. So we need to see which is larger, which is smaller. Now, when we're comparing numbers, if a number is a whole number and it has more digits, it will always be larger than a number with fewer digits. So 350 is a 3-digit number and 35 is only a 2-digit number. So because 350 has 3 hundreds and 35 doesn't have any hundreds, we know that 35 must be less than 350. So we need the symbol for less than. The way to remember this symbol is that we can imagine this is a kind of point and it always points to the smaller number. Another way of thinking about this symbol is to imagine it's like the mouth of a crocodile or an alligator, and the crocodile snaps at the larger number, so its mouth points towards the number that's larger. Now we have 492 and 509. Now when we're comparing numbers, we always start by comparing the larger place values. Remember, ones are smallest, then tens, then hundreds. So because both of our numbers are 3-digit numbers, they have the same number of digits, we need to look at the hundreds digit first. Now this number has 4 in the hundreds, but this number has 5. So 492 must be less than 509 because it has fewer hundreds. Now it doesn't matter that this number has 9 tens and this number doesn't have any because tens are smaller than hundreds. We need 10 tens just to make one more hundred. So when we're comparing numbers, we need to start by comparing the larger place values first. Now we have 472 and 427. So both of our numbers have 4 as the hundreds digit. So what we need to do now is to move along and compare the next digit along. So compare our tens digits. Here we have 7 tens, but here we only have 2. So that means that 472 must be greater than 427. So we need our greater than symbol. Finally, let's compare 479 and 474. Here, both numbers have 4 as the hundreds digit and 7 as the tens digit. So we need to move all the way along and compare our ones digits. Here we have 9 ones, but in this number we only have 4. So that means 479 is greater than 474. So now what we can do is show base 10 blocks for the numbers that we were comparing. 350 means that we have 3 hundreds, but with 35 we don't have any hundreds, so we know that 350 is larger. Now with 35 we have 3 tens and 5 ones, and for 50 we can show 5 tens, but the tens and ones don't really matter, because tens and ones, it doesn't matter how many you have of each, it will always be less than just 100. Then we had 492, so that has 4 hundreds, and 509, which has 5 hundreds. So because 509 has more hundreds, we know that it's larger. 492 is less than 509. Now it doesn't matter that with 492 we have 9 tens and 2 ones, and with 509 we don't have any tens and just have 9 ones, because even all of these tens and ones together add up to less than just one of these 100 blocks. Then we had 472 and 427. So with both numbers we have the same number of hundreds, but with 472 we have 7 tens, and with 427 we only have 2 tens. So we know that 472 must be larger, even though it only has 2 ones, but this number has 7. Then we had 479 and 474. Now both numbers have 4 hundreds, and they both have 7 tens. But because our first number has 9 ones, and this number only has 4, we know that 479 is greater than 474. So we've been using base 10 blocks, but we could also use place value counters to compare numbers. So 35 is less than 350, because with 35 we have 3 tens and 5 ones, but with 350 we have 3 hundreds and 5 tens. Now remember, we need 10 ones just to make 1 10, and we need 10 tens just to make 100. Then we had 492, so that's 4 hundreds, 9 tenths and 2 ones, and 492 is less than 509, so that's 5 hundreds, no tens and 9 ones. Now it doesn't matter that 492 has 9 tenths and 509 doesn't have any, because remember, we need 10 tens just to make something that's the same value as 100. So, because 509 has more hundreds, we know that it must be larger. Then we had 472, so that's 4 hundreds, 7 tenths and 2 ones, and we were comparing that to 427, so 4 hundreds, 2 tenths and 7 ones. Now, because both numbers have the same number of hundreds, we compared the tens. Because our first number has more tens, we knew that it must be greater. Now it doesn't matter that the second number has 7 ones, because remember, we need 10 ones just to make 1 10. Then we had 479, so that's 4 hundreds, 7 tenths and 9 ones, and we found that that was greater than 474, so 4 hundreds, 7 tenths and 4 ones. Both numbers have 4 hundreds and 7 tenths, but because our first number has more ones, we know that it must be greater. We need to write the numbers below in order from smallest to largest. So in our first set of numbers, we have 671, 67, 706, 660, and 716. Now 67 is a 2-digit number, but all of our other numbers are 3-digit numbers. And if a number has fewer digits, and it's a whole number, it will be smaller. So our smallest number is 67, because it doesn't have a hundreds digit. Then, if we look at our hundreds digits, because remember, we compare numbers by comparing the larger place values first, so first comparing our hundreds before we compare our tens or ones. We have 2 numbers with 6 hundreds and 2 numbers with 7 hundreds. So if we focus on the numbers with 6 hundreds to decide which number is next smallest, we need to look across at our tens digit. Here we have 7 tens, but here we only have 6 tens. So 660 is our next smallest number, and then we have 671. So that leaves us with these 2 numbers, which both have 7 hundreds. So again, we need to look across at our tens digits. Here we have a 0, and in this number we have 1 as our tens digit. So that means 706 is next smallest, and then our largest number is 716. Now we have 405, 504, 44, 405, 454. So again, 44 is only a 2-digit number, so it doesn't have a hundreds digit. But all of our other numbers are 3-digit numbers, so our smallest number is 44. Now, if we compare the hundreds digits, we have 4, 5, 4, and 4. So we know that 504 must be our largest number because it has the largest number of hundreds. So now we have 3 numbers that all have 4 hundreds. So what we need to do is compare the tens digits. We have 0, 0, and 5. That means that this number with 5 tens must be second largest. And then if we look at our remaining two numbers, this number has 5 ones, but this number only has 4. So 404 is next smallest, and then we have 405. So let's take a look at the numbers we compared. In this first set, our smallest number was 67, so that's 6 tenths and 7 ones. Then we had 660, so 6 hundredths and 6 tenths. Then 671, so 6 hundredths, 7 tenths and 1 one. Then we had 706, so 7 hundredths and 6 ones. And then our largest number was 716, so 7 hundredths, 1 10 and 6 ones. Then for our next set, our smallest number was 44, which only has 4 tenths and 4 ones. Then 404, which has 4 hundredths and 4 ones. Then 405, so with 5 ones. Then 454, so 4 hundredths, 5 tenths and 4 ones. And our largest number, because it had the most hundreds, was 504. So that's 5 hundredths and 4 ones. Now we need to round the numbers below to the nearest 10. So first we have 42. Because we're rounding to the nearest 10, what we need to do is circle our tens digit, and then we underline the digit to the right. So we underline our ones digit. And the digit that we've underlined decides whether we're going to round up or down. So when it's 5 or more, we round up, but when it's 4 or less, we round down. And because we have a 2, which is 4 or less, we're rounding down. Now when we round down, the digit that we've circled stays the same. So this 4 is going to stay a 4. And digits to the right turn into zeros. So we get 40. 42 rounded to the nearest 10 is 40. And if we show the number 42 on a number line, we can see that the previous multiple of 10 is 40 and the next multiple of 10 is 50. Remember, multiples of 10 are what we get when we count in tens. So if we counted in tens, we would count 10, 20, 30, 40, 50, and 42 is between 40 and 50. But because, as we can see on this number line, it's closer to 40, that's why we round down to 40. So now let's try 58. Again, we can circle our tens digit because we're rounding to the nearest 10 and underline our ones digit. This time we have an 8. And remember, if we have 5 or more, we round up. Now when we round up, the digit that we've circled increases by 1. So this 5 is going to become a 6. The ones digit turns into a 0, so we get 60. Again, we can show 58 on a number line. It's between 50 and 60. So if we counted in tens, we would count 10, 20, 30, 40, 50, and then 60, and 58 is between those multiples of 10. But because it's closer to 60, that's why we round up. So that's why looking at our ones digit decides whether we're rounding up or down. Now 28, we circle our tens and underline our ones because we're rounding to the nearest 10. We have another 8 as our ones digit, so we need to round up because if we have 5 or more, we round up. So the digit that we've circled, our tens digit, increases by 1, so this 2 becomes a 3, and the ones digit turns into a 0, so we get 30. And again, on a number line, we can see that 28 is between 20 and 30, but because it's closer to 30 than it is to 20, that's why we round up. Now 81, so we circle our tens and underline our ones. We have a 1, and remember, if it's 4 or less, we round down. That means our tens digit stays the same, and the ones digit always turns into a 0, so we get 80. And on a number line, we can see that 81 is closer to 80 than it is to 90. Now 35, so we circle our tens and underline our ones. Now, because when we have 5 or more, we round up, this 3 is going to become a 4, so we get 40. Now 35 is between 30 and 40, and 35 is exactly halfway between those multiples of 10, so it's right in the middle. But even though 35 isn't any closer to 40 than it is to 30, if it's right in the middle, we always decide to round up rather than down. So that's why if the ones digit is a 5 or more, we still round up. So for 85, we can circle our tens and underline our ones, and again we need to remember that if it's 5 or more, we round up. So the 8 becomes a 9, the ones digit turns into 0, so we get 90. And again, we can see 85 is right in the middle of 80 and 90, but if it's right in the middle, we always round up. We need to round the numbers below to the nearest 10. So first, we have 215. Because we're rounding to the nearest 10, we need to remember the place value of each digit. So in a 3-digit number, we have our hundreds, then our tens, then our ones. So because we're rounding to the nearest 10, we can start by circling our tens digit, and then we underline the digit to the right. So underline our ones digit. We can see that we have 5 ones, and if we have 5 or more, we round up. So because we're rounding up, this 1 is going to become a 2, because rounding up increases the place value we've circled by 1. Now digits to the left of what we've circled always stay the same, and digits to the right turn into zeros, so we get 220. The 2 in our hundreds stays the same. Because we're rounding up, the 1 in our tens turns into a 2, and when we're rounding to the nearest 10, the ones digit always turns into a 0. Now on a number line, we can see that 215 is between 210 and 220. So the closest multiples of 10 are 210 and 220, because if we were to keep on counting up in tens, so 10, 20, 30, 40, and so on, we would eventually get to 210, then 220, and 215 is between those numbers. Now 215 is right in the middle of 210 and 220, but if it's right in the middle, when we're rounding, we always round up. Now we have 492. Again, we can circle our tens digit and underline the digit to the right, underline our ones digit. So remember, 5 or more, we round up, but 4 or less, we round down, and we have a 2, so we're rounding down. That means the digit we've circled stays the same, so we have 490, because digits to the left stay the same, and because we're rounding to the nearest 10, our ones digit turns into a 0. And on a number line, you can see that if we were to count up in multiples of 10, 10, 20, 30, 40, and so on, we would eventually get to 490, and then the next multiple of 10 is 500, and 492 is between those numbers. But because 492 is closer to 490, that's why we round down. So that's why looking at our ones digit helps us decide whether we're rounding down or up. If it's 4 or less, we round down because that means it's closer to the previous multiple of 10. Now let's round 333 to the nearest 10. So we find our tens digit, underline our ones, and because it's 4 or less, we're rounding down. So the tens digit stays the same, giving us 330. On a number line, we can see 333 is between 330 and 340, but it's closer to the previous multiple of 10, so that's why we round down. Now 897. So we can circle our tens digit and underline our ones. Remember, if it's 5 or more, we round up, and we have a 7, so we're rounding up. Now that usually means the tens digit increases by 1, but we already have a 9 in our tens, and we can't write 10 in our tens because we can only have one digit in each place value. So what we need to do here is look to the left and take our hundreds and our tens digits together. Remember, when we're rounding up, what we've circled increases by 1, and 1 more than 89 is 90. So these digits here change to a 9 and a 0 because 1 more than 89 is 90, and as always, our ones digit turns to a 0, so that's why we have 900. On a number line, we can see that 897 is closer to 900 than it is to 890. Those are the multiples of 10 that it's between, because if we counted up in tens, we would say 890, and then the next multiple of 10 would be 900. But it's closer to 900, so that's why we round up. Finally, we have 303. To round to the nearest 10, we find our tens digit and underline the place value to the right. If it's 4 or less, like it is here, with a 3 in the ones, we round down. So that means the digit we've circled stays the same. Digits to the left always stay the same, digits to the right turn into zeros, so we get 300. 303 is closer to 300 than it is to 310, so that's why we round down. We need to round the numbers below to the nearest hundred. First, we have 215. Now because we're rounding to the nearest hundred, the first thing we do is find our hundreds digit. So that's the first digit of a 3-digit number because we have ones, then tens, then hundreds. Then we underline the digit to the right. So we underline our tens digit because when we're rounding to the nearest hundred, it's the digit to the right, it's the tens digit that decides whether we're going to round up or down. Now if we have 5 or more, we round up, but if we have 4 or less, we round down, and because we have a 1, we're rounding down. That means the digit that we've circled, so our hundreds digit, is going to stay the same. So we get 200, because digits to the right of what we've circled turn into zeros. So on a number line, 215 is between 200 and 300. If we were counting in hundreds, we would count 100, then 200, then 300, and 215 is between those multiples of 100. Now, notice when we're rounding to the nearest hundred, we look at our tens digit, and each square on this number line is an increase of 10. So this here is 210, 220, 230, 240, 250, and so on. So 215 is between 210, which is here, and 220. But because it's closer to 200 than it is to 300, that's why we round down to the previous multiple of 100. So 215 rounds to 200. So now let's try 492. We're rounding to the nearest hundred, so we circle our hundreds digit and underline the digit to the right. If we have 5 or more, we're rounding up, and we have a 9. So when we round up, the digit that we've circled, the digit that we're rounding to, increases by 1, which means this 4 is going to become a 5 to give us 500, because, again, digits to the right of what we've circled turn into zeros. Now, if I were counting in hundreds, I would count 100, 200, 300, then 400, then 500. And 492 is between those multiples of 100. But because it's closer to 500, we round up. Remember, each of these squares is an increase of 10. So this line here is 490, so 492, just a bit more than that. But it's closer to 500 than to 400, so we're rounding up. And that's why, to decide whether we're rounding up or down, if it's to the nearest hundred, we need to look at our tens digit. Now we have 333. We can circle our hundreds digit and look to the right. It's 4 or less, it's a 3, so we're rounding down, which means the 3 in our hundreds stays the same, giving us 300. On a number line, 333 is closer to 300 than it is to 400, so that's why we round down. Now 897. We look at our hundreds, then look to the right. It's 5 or more, so we're rounding up, which means we need to add 1 to the digit that we've circled. So this 8 becomes a 9, giving us 900. On a number line, 897 is between 800 and 900, but it's much closer to 900. Remember, if we're counting in tens, we have 850 right in the middle, 860, 870, 880, 890, so 897 is closer to 900. And finally, we have 303. We find our hundreds and look to the right, and we have a 0 in our tens. If it's 4 or less, like it is here, we round down, which means the digit that we're rounding to stays the same. So we have 300. On a number line, we can see 303 is much closer to 300 than it is to 400 than it is to the next multiple of 100, so that's why we round down.